This is Note-Taking Guide 4.4, Solving Radical Equations. So the last couple of days we've learned how to graph some cube root functions and square root functions. We also learned how to find their inverses. What we're going to do today is to find the point of intersection between two different functions, or how to solve them algebraically if we don't want to graph them. So if we wanted to solve an equation that looks like this, it's really quite messy. What we're going to do is we're going to take one side of the equation and graph it, and the other side of the equation and graph it, and then we're going to find their point of intersection. If you notice this side over here, that's a square root graph. So what they did here was they graphed a square root graph. They went 3 to the left and down 5. So 3 left, down 5, started their point there, followed the pattern, up 1 over 1, up 1 over 3, up 1 over 5, and they graphed it. Then they looked at the other side of the graph, which was just a line. This is in y equals mx plus b form. The b value would be 0 because we didn't have an up or down movement going on with that line. So they started at 0, 0, and they followed their slope, down 1 and over 3. And then they just graphed their line through those ordered pairs. Once they got the two graphs on the graph together, then they totally just found the point of intersection. The point of intersection right there is at x equals 6 and y equals negative 2. So our solution is x equals 6. All right. So sometimes we don't want to use graphing to do it, but we're going to use graphing this time, and then next time we're going to show you how to do it algebraically. So if I look at this side of my function, this is a square root graph. The plus 2 asked me to move left 2. The plus 6 asked me to move up 6. So I'm going left 2 and up 6 to start for my starting point. And then because this negative is out front, that changes my y values to be negative. So if I'm going to go up 1 over 1, I would actually be going down 1 over 1, down 1 over 3, and down 1 over 5 for my graph. So my graph is going through those ordered pairs. All right, I'm going to change colors and graph in a different color for this next section. This is actually a line in y equals mx plus b form, and it's ready to go. It says to start up at 3. So I start up at 3, and then I follow my slope up 1 and over 2. So my line goes through those ordered pairs, and I actually just found my point of intersection. Because x is 2 at the point of intersection, my solution is going to be 2. So sometimes we don't want to graph, sometimes we just want to use algebra in order to solve. So here's a step-by-step on how to do that. It says to write the original equation first, and then in this case isolate that radical, and it is isolated here, so we're going to cube both sides to get rid of the cube root. We're going to simplify it by getting the variable by itself on one side of the equation, and then just solve it until we get our solution. Now we always want to check our solution to make sure that it works, so we're going to substitute it back in. And the reason that we need to do that is because some of our functions are going to have domain errors, and if we can't remember which ones are going to have domain errors, we might as well just check them all. So we're just going to get in the habit of checking them all. Okay? All right, so here we go. We're going to solve this one by ourselves. So in order to solve this one, I need to isolate the radical. That 2x plus 9 that's underneath the square root, it needs to be by itself on one side if at all possible. Because otherwise you're going to have to do some messy math with it. So the first thing I want to do is add that 5 over to the other side. So I'll have the square root of 2x plus 9, and it's equal to 5. Before I can move the 9 or the 2, I'm going to have to get rid of that square root. And in order to get rid of a square root, I'm going to have to square. So I'm squaring both sides now. It cancels on this side to just be 2x plus 9. And on the other side, I have 5 squared, which is 25. Subtract 9 from both sides. When you do that, you get 2x equals 16. Divide both sides by 2. And you get x equals 8. Now again, just really fast, what we want to do is we want to take that 8 and we want to plug it back in there real fast. So I just kind of like to do it in my head. 2 times 8 is 16. 16 plus 9 is 25. 25 square rooted is 5. 5 minus 5 is 0. So that did check out. So I know that this is my solution. So again, step by step how to do it. This one's a little bit messier because it has that 2 on the bottom, but the very first thing you're going to do, or that first step that you're going to do there, is you're going to multiply both sides by 2, and it tells you step by step over here how to do that. If you multiply both sides by 2, it cancels over here just to be x minus 1 square rooted plus 3, and on this side you would get it equal to 10. I'm still trying to isolate that square root, so I'm going to subtract a 3 over next. So I'll have the square root of x minus 1 equals 7. So that was the step that I just did. We're going to square both sides next to get rid of that square root. When I do it on this side, it cancels to x minus 1. When I do it on this side, I get 7 squared, which is 49. Still trying to isolate the x, so I'm going to add 1 to both sides. So I get x equals 50. Then again, my very last step is to check that really fast. So I'm going to take that 50. I'm going to substitute up in here in place of the x. So 50 minus 1 is 49. 49 square rooted is 7. 7 plus 3 is 10. 10 divided by 2 is 5. So that checked out. When it checks out, we know that our answer is correct. All right, here's another one. Again, isolate and the radical, we need this by itself. So the first thing I need to do is get rid of that 2. The 2 is times by there, so I'm going to divide. It cancels over here, and on this side I get the cube root of x minus 3, and on that side I get 4 divided by 2, which is 2. To get rid of a cubed now, or a cubed root, I guess I should say, I need to cube both sides. When I cube both sides, it cancels over here to just be x minus 3. On the other side, I need 2 cubed, which is 2 times 2 times 2, which is the number 8. Last step is to add 3 to the other side, so I get x equals 11. Then I'm going to sub that in real fast to make sure that it works. So I do 11 minus 3, which is 8. 8 cubed rooted is 2. 2 times 2 is 4. So this checked out. X equals 11 is my solution. All right, this last example is a word problem. It says, for a pendulum, the time of one cycle and the length of the pendulum are related, such that t equals 2 pi square rooted L over 32. Where t is the time in seconds and L is the length. So t is time in seconds, L is the length. If the swing of the pendulum takes 8 seconds, so that's actually t in time, so 8 seconds to complete a full cycle, what is the length of the pendulum? So we're actually going to substitute 8 in for t here, and we're just going to solve it really fast. So we'll have 8 equals 2 pi times the square root of L over 32. And we are going to solve that. The first thing we're going to do is divide both sides by 2 pi. And we can just let our calculator do that work for us. So 8 divided by 2 pi. That's roughly 1.27. So I'll have 1.27 equals the square root of L over 32. To get rid of the square root, I'm going to square both sides. So 1.27 squared is 1.613. That will be equal to L over 32. To get L by itself, I'm going to multiply both sides by 32. And when I do that, I get the length is equal to 51.6128 if I want to go out that far. Okay, so the second part of the problem asks you to do the exact same thing, but this time you're going to substitute 26 seconds in to find the length of the pendulum. So I'm going to let you do that one on your own. If you need to check your answer, come and see Mrs. Clark's note-taking guide, and I'm happy to give that to you. Thanks for watching, guys.